Welcome to Easy Math TV. We are going to start a series on using R in the form of Posit Cloud, which is the new version of RStudio, in order to do some of the statistics calculations, making plots, graphs, things like that in our statistics class. So this first video concerns just doing basic exploration of our data. And in front of us here, we see the what the window looks like, or the browser window looks like when we are in Posit Cloud and we have created a new RStudio project. So this is just a plain vanilla RStudio project in Posit Cloud. And what I've done is I've named it Exploring Data. So everything that you see here is just automatically put into the framework for our new workspace that we're going to be using. So the first thing I'm going to do is I'm going to create a new folder just because I would like to organize all of my work into folders. I'm going to continue to just use this workspace for any projects or any code that is just meant to summarize my data. So if all I'm doing is doing some basic summarizing of data, I'm going to be using this workspace. And we're starting out with just a single data set. So like instead of tabular data or instead of tabled data, what if all you have is just a single set of numbers that you're looking at? So I'm just going to call this my simple data. My simple data. Okay, so I'm going to open it. And now there's nothing in there yet. What I'm going to do, though, is I'm going to upload a file that my professor gave me. So I'm going to upload. And what I need to do is I need to actually choose it from my computer. So I need to locate that file. And what I've done is I've downloaded it. And you can see like there's a whole bunch of files here that I have personally downloaded over the past couple of weeks, and I haven't actually deleted any of the stuff that's in there. But if I organize it by date modified, I should see the most recent file that I've downloaded here, and I called it samplesummary.r. So that's the file that my professor gave me. So I'm actually going to upload that now into my the folder that I created. Notice it's going to go inside of that folder that I've called my simple data. All right. So there's the name of the file, and this is the folder that it's going into. So I'm going to click OK, and there it is. So in a moment, I'm going to click on that, and what I want you to notice is that on the left-hand side of my screen right now, the entire left-hand side of the screen is taken up with what we call the console, which is the place where you can just type in a single line of code and run it and see what happens. But we're going to be running like a whole series of commands. So I would like to basically be able to just use this entire set of code that my professor gave me so that I can answer some basic homework questions. I'm going to click on it and notice that it immediately appears up here in the upper left corner. The console has been pushed down to the bottom. We can actually get rid of the console altogether if we want, but it's probably not a good idea to do that because any calculations that are performed up here when I run the code, any calculations that are performed are going to appear down here in the console. And the other thing I'm going to do then is I'm going to switch from seeing the Files tab to the Plots tab. So the tabs that I have open right now are my file itself that has all my code in it. That's my samplesummary.r. Below that is the console. In the upper right is what's called the environment. And then in the lower right is called plots. So I made sure that I have the plots tab selected. And I may move things around, like you can actually expand the sizes of some of these things just so you can see more or less. And so that file that I was just given is displayed up here, and there's a lot to read here in the comment. And basically, this document can be uploaded into a folder into your workspace. And what does this R program do? It calculates the mean, standard deviation, median, and then Q1, Q3, and the interquartile range, IQR, which also means that it calculates the minimum and the maximum values of a sample, a single sample of numeric data. And it says, note, the minimum, Q1, median, Q3, and maximum are what we call the 5-number summary. Those are percentiles based on the 25th, like the 0th percentile, the 25th percentile, which is Q1, the 50th percentile, which is your median, the 75th percentile, which is Q3, and then the maximum, which is 100 percentile of your data. So it basically measures where you are. If you're 25% into your data set from smallest to biggest, where's the 50th percent location, where's the 75th percent, and where's the 100%. So it divides your data into equal-sized quarters. We're also going to create a box and whisker plot of the data. From this, we're going to be able to determine if there are any potential outliers. So you're going to see that in a moment. And then we're also going to create a histogram, although the histogram is not very useful if you have a really small data set. Histograms are more accurate or more helpful if you have more values in your data set than just 15, for example. That's just a rough number that I gave. That's not an exact thing. But if you have fewer than 15 values, a histogram isn't very helpful to you. Anyway, but it does show us if we have more values to look at, it can show you whether you have skewness in your data. So like skewness is indicated also by outliers, okay? So that's what we're going to be able to see. So we're going to be able to answer some homework questions based on just running this code. Like I don't even need to type in anything myself except for right here where it says my data. So let me click on homework 3. And on homework 3, there's different data sets that we're going to be looking at. I'm going to focus on the ones that are given to us here. So let's look at question 5 and look at data set 2. Data set 2 says we only have these 5 values, 3, 5, 6, 7, and 20. So over here, I'm going to uncomment, which means removing the hashtag in front of this statement that says my data equals, because there's 5 values there. So it's very easy to just adjust those. And let me go back and remind myself. So it's 3, 5, 6, 7, and 20. Okay. 3, 5, 6, 7, and instead of a 9 there, let's change that to a 20. So we've got our 5 data values, and we're calling that my data. Everything else this is all commented out because we're not using that right now. These are the only formulas that we're actually going to be using. The mean, the standard deviation, the quantile function, the IQR function, and then creating a box plot and a histogram. All right. And you'll notice that the file name changed from black to red because I made a change to it. So I can actually hit save, to save any changes that I made, and I'm going to highlight or select the set of the data that I want to actually run. So starting with the statement my data equals all the way down to the bottom, I've highlighted all of that, and I'm going to click run. So in the console below, so I can expand this a little bit now, we can see some calculations that we made. It'll show us also all of the statements that were executed. So it'll even show us the comments, even though those are just kind of ignored. It doesn't mean anything, they're just comments. But the information that we need to be able to type into our homework problem, though, these are the results of that. So anything that you see here that's in black, the mean is going to be 8.2. The standard deviation is 6.76, or depending on how many digits you're supposed to round to. But I think in this case, it's probably 2 decimal places, so it would be 6.76. And then here are your quantiles. This is your minimum. Your Q1 is the 25th percentile. Your median is the 50th percentile. Q3 is the 75th percentile. And then the maximum is the 100th percentile. So here's your minimum, Q1, median, Q3, and maximum of 20. The interquartile range is 9.5. So those numbers can be typed into my homework, but I want to show you what the box plot actually looks like. If you notice, there are, this is called a box and whisker plot for a reason, and the whiskers only go up to within 1.5 times your interquartile range. Once you go outside of that range, you're going to see you might see a little dot. So notice up here for the data value of 20, we have a dot outside of the whisker. There is no whisker at the top because there was no data that was inside of that range. So that is called a potential outlier. When you see a dot appear in your box and whisker plot, then you can say yes to the answer of outliers, and that also indicates that your data is skewed to in this case it would be to the right, because these are the larger values. If the outliers are the larger values, it's skewed right. If the outliers are the smaller values, then it's skewed left. And here's our histogram. So the histogram, like I said, it's just too small of a data set to really be able to read your histogram very well. But it does show a gap. It does show that gap between the lower values and that upper outlier. So, you know, that can indicate that you have skewed data as well. Okay, so that's just that data set. I want to just run this one more time instead of on the homework data. So I'm going to put a hashtag in front of that. Let's uncomment these lines here. So all the way down to that parenthesis. Okay, so this is one statement. I just hit enter so that we would be able to visualize this and not have the numbers spilling off to the right. But from the left parenthesis to the right parenthesis with a little c in front, that means that these are our values that we're looking at. And I'm going to call this my data. Now we have quite a few more values that we're seeing. So, you know, this might make things a little more interesting. So I'm going to highlight again, and I'm going to hit run. And let's expand back up here. So now I've calculated again with the mean and the median and all that. So the mean is 19.375. The standard deviation is 3.7133532. And then here's our 5-number summary. The minimum, Q1, the median, Q3, and the maximum. They're listed right there, 12, 17, 20, 22, and 28. So the interquartile range is 5 because you take your Q3 minus your Q1. That's your interquartile range. And then over here on the right in the plots window, we see the histogram, and we also see what the box and whisker plot looks like. And notice that the whiskers are much more symmetric. The box itself is much more symmetric. There are no outliers in this data, and the histogram is roughly symmetric as well. It may not look perfect, but it is roughly symmetric. So you just saw an example with data that was kind of skewed, but you also saw an example with data that was symmetric, and answering your questions about what the measures of center, mean, and median versus measures of spread, which are standard deviation and interquartile range. So you can basically answer those questions in any situation. Okay? Like, subscribe, comment down below. Make sure you share these videos with other people that are taking stats and need to use R, need to use the programming language R, and I'll see you in the next video.